Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we will be continuing further with Mathematics class 11th, and the chapter that we are dealing with is straight lines. It is time to deal with exercise number 10.3 now, and exercise number 10.3 is kind of an application based exercise, application of the concepts of various types of equations of straight lines, and how do you use various types of equations, various forms of equations of straight line to solve questions of let's say general equation of straight lines, right? How do you find the x-intercept, how do you find the y-intercept, how do you find the slope, and related questions based on those things, right? A few more important concepts were discussed in theory with respect to this particular exercise, that is distance of a point from a line, and some other, let's say there were some examples based on finding the image of a point in some particular line. So all of those things will be covered here one by one. So along with the questions, we'll be discussing the concepts as well. So let's begin with the first question now. The first question says that reduce the following equations into slope-intercept form, and find their slopes and the y-intercepts, right? Now what is slope-intercept form? If you may recall, slope-intercept form for this x-axis, this y-axis, and this line which has this y-intercept as c and slope of this line is m, the equation will be y is equal to mx plus c. So for writing any equation in slope-intercept form, you have to bring y on the left hand side and rest everything on the right hand side. The coefficient of mx will give me the slope and the constant term will give me the y-intercept, right? Bring y on the left hand side. This is the form in which we want to finally bring any equation that comes in front of us, right? So reducing the equations into slope-intercept form, that implies in the first part, what you have is x plus 7y is equal to 0. So let's bring y on one side and the rest things on the other side. This is minus x, okay, and dividing by 7, this becomes minus 1 by 7x, okay, and plus at max you will have a 0 over here, right? So this is the idea behind this. And after reducing into the slope-intercept form, we are supposed to find the slopes and y-intercept. Now slope is, as you can clearly observe, slope, that is value of m will be minus 1 upon 7, that is the coefficient of x, and the y-intercept, after reducing in this form, y-intercept is denoted by this c, which is simply equal to 0 over here. This is what we have, right? Slope denoted by m is minus 1 by 7 and y-intercept is 0 for this first part, as you can clearly see, right? Let's deal with the next part after this. What do we have? Second part says that you have 6x plus 3y minus 5 is equal to 0. So we'll keep terms of y on one side, rest everything on the other side. This is what you get, right? Dividing by 3 further will tell me that this becomes minus 2x plus 5 upon 3. And this here is the slope, this here will be the y-intercept, right? Therefore, m is equal to minus 2 and c is equal to 5 by 3 are the respective slopes and y-intercepts correspondingly. What about the third part? Let's deal with the third part after that. The third part says that you have this equation y equals 0. Okay, now that's interesting. You already have a y on the left hand side and you have everything else on the right hand side, nothing else. Basically this is simply 0. So I can write it as actually 0 times x plus 0. Please observe this carefully. I'm writing this as this. Is that okay? Yes. So slope is 0 and the y-intercept is also 0. That's what you can guess on the basis of this equation, right? That's what we have in this first question, as you can clearly see behind me. The second question says that reduce the following equations into intercept form and find the intercepts on the axis. Now, what is the intercept form first of all? So intercept form looks something like this. Let's suppose this is x-axis and y-axis. This is x, this is y-axis, and we have this kind of a line. Okay, if this is x-intercept, point A having coordinates a comma 0, and this is point B having coordinate 0 comma B, then the equation becomes x upon A plus y upon B is equal to 1. This is the equation in intercept form, right? What's special about this particular equation is all terms having x and y are on the left hand side. Terms having x and y are on the left hand side. Okay, you have a plus x, you have a plus y, and something in there is in the denominator. In the right hand side you have a 1. So this is my target. This here is my target. That is, you should get a 1 on the right hand side. Okay, that constant term should be 1, and that's the key to converting any equation in the intercept form, right? And how do we do that? Let's take a look at this question. So first what we will do is we'll keep all terms having x and y on the left hand side and bring the constant term on the right hand side. Okay. After that we'll divide by the constant term to give us this particular form, right? So first part has 3x plus 2y minus 12 is equal to 0. Okay. Let's bring this 12 on the right hand side. 3x and 2y will remain on the left hand side. This is equal to 12. And now we'll divide by 12. So this becomes on dividing by 12. Okay. Divide the complete equation by 12. This is what we are doing on the left hand side as well as right hand side. This gives me 3x upon 12 becomes x upon 4 plus y upon 6 is equal to 1. And this is my required intercept form. First of all, reduce the following equations into intercept form and find their intercepts on the x and y axis. So x intercept is basically when this is plus x, the denominator gives me the x intercept. This is 4. X intercept is 4. Y intercept is 6, as you can clearly observe over here. Yes, this is the final answer for this first part. After this, let's talk about the second part over here. What does the second part have? So second part has 4x minus 3y. The equation is 4x minus 3y is equal to 6. If you observe carefully, what do we have? We have all terms on the x having x and y on the left hand side and we have constant on the right hand side. So simply divide by 6 is what we are supposed to do. Let's do that. This becomes x upon, this is 4x upon 6, which becomes x upon 6 by 4 plus y upon 6 over minus 3. Observe carefully what I have done over here. This was 4x upon 6. I have to bring that 4 down because the coefficient of x is supposed to be 1, right? Coefficient of y similarly has to be 1. So I have to bring that minus 3 in the denominator. This actually is equal to 4x upon 6 minus or plus minus 3 y upon 6 is equal to 6 upon 6. And this is the middle step which I have skipped. I think you can handle that much. Yes. And once you write in this form, this can be further written as x upon, this becomes 3 by 2 plus y upon minus 2 is equal to 1. And this is the required intercept form first of all. This is the required intercept form, as you can clearly observe using that. And x intercept is equal to 3 by 2. Y intercept is equal to minus 2. That's what we have. X intercept is 3 by 2. That is the denominator of x, and y intercept is minus 2. That is what that you have. What about the third part? So third part, we have 3y plus 2 equals 0. What we'll do is, okay, we have no term of x. Okay, that's pretty interesting. So you will write it as 3y is equal to minus 2, and further you can write it as y upon minus 2 by 3 is equal to 1. Dividing by minus 2 and bringing that 3 down, the coefficient of y. Okay, what about x? Since there is no term of x, do you observe that there is no intercept with x-axis? There is no intercept with x-axis. You can also observe this directly with this particular idea that the graph of this will be y is equal to minus 2 by 3. This will be the line. This is x-axis. This is y-axis. This is the line y is equal to minus 2 by 3. And does this line, which is parallel to the y-axis, does this line intersect with the x-axis anywhere? No, it will keep on continuing along with this, and these will be parallel lines. Therefore, it does not have any x-intercept. This is my required intercept form, and no x-intercept. That's what you can observe. What about y-intercept? Y-intercept will be minus 2 by 3. That's my answer for this particular part over here, and that's the complete solution of this question. The third question says, reduce the following equations into normal form. Pretty interesting. Normal form is something to look forward to. Find their perpendicular distances from the origin and the angle between perpendicular and positive x-axis. Positive x-axis, right? So, normal form. Now, what does a normal form look like? Normal form, for the normal form, we need two things. What is that? One is, for any line, we need this perpendicular distance from the origin. Okay. And the next thing that we need is this angle made by this perpendicular with positive x-axis. Now this alpha can be 0 to 90 or 180 or 270 or up till 360. Basically it will lie between alpha belongs to 0 comma 2 pi. This is what we have, right? At 2 pi I have written an open bracket because 2 pi is same as 0 for that matter. P is supposed to be greater than 0. This is another important thing. And then the equation of this line L, is x cos alpha plus y sin alpha is equal to P. This is the equation of line. Okay. For converting any given equation in the normal form, what are we supposed to do? So for converting any equation, we'll have to write in this particular form first of all. And how do we do that? Let's take a look at the first part. The important thing to do here is equal to plus 8 is there. Just a minute. Let me write this complete statement first. This is plus 8 is equal to 0. Okay. The important step that we want to follow over here is, you observe this is cos alpha and this is sin alpha. So squaring this and adding will give me 1, right? And that is the key. That is the most important thing. The second most important thing is this right hand side should be positive. That's something which is important, right? So if I want to convert the coefficient of x in terms of cos alpha and sin alpha, I'll have to divide with this coefficient of x is 1, this is coefficient of y is minus root 3. I'll have to divide both sides by bringing the constant term on the right hand side first, divide both sides by under root of a square plus b square. For example, you have the important step for ax plus by plus c equal to 0. The first thing that you are supposed to do is bring this c on the right hand side and then divide both sides by under root of a square plus b square over here, and here also under root of a square plus b square. Okay. After that, the next step will be to simply convert this whole expression into a positive value. Convert this whole expression because this right hand side is supposed to be positive. So if required, multiply with the minus, and then this here will give me x, the coefficient of x will be a upon under root of a square plus b square or minus a upon under root of a square plus b square. That will give me cos alpha. This here b or minus b upon under root of a square plus b square will give me sin alpha, right? On the basis of that, I can easily guess the value of alpha. And once alpha is known, once p is known, this is the normal form. And the person has also asked us, and the angle between perpendicular, okay, perpendicular distance, that is p is asked, and the perpendicular angle between perpendicular and the positive x-axis, that is alpha is asked. So we are supposed to find p and alpha for each of these equations after converting in the normal form. That's what we are supposed to do, right? So let's take a look at this. This is x minus root 3y plus 8 equals 0. And the important thing to do here is that let's convert this will be written as minus 8. Divide by under root of a square plus b square. Now what is a square? 1. What is b square? Is minus root 3 whole square, which is 3. 1 plus 3 is 4. Okay. And under root of 4 will be 2. So we'll have to divide by 2 here and we'll have to divide by 2 here, since under root of 1 square plus minus square root of 3 whole square, this is simply equal to 2, since this is the case. Okay. And once I do that, I'll write it as this is x by 2 minus root 3 by 2 y is equal to minus 4. But still, you'll have to focus next thing, which what you're supposed to do is make this positive, right? So for making this positive, what I'll do is I'll multiply throughout with the minus. This will become minus 1 by 2 and coefficient of x, this is the coefficient of x, plus square root of 3 by 2 with y is equal to 4. So one thing is for sure, one thing is certain, that therefore p is equal to 4, this is certain, and cos alpha is equal to minus 1 by 2, sin alpha is equal to root 3 by 2. Okay. Which quadrant is this? If cos is negative, sin is positive, so you're actually looking forward to this particular second quadrant, right? And in the second quadrant, if you observe sin alpha is equal to root 3 by 2, implies alpha will be equal to pi by 3, and then pi minus pi by 3 is another value, and cos alpha is equal to minus half will also give me this. Therefore, alpha is equal to pi minus pi by 3, which is 2 pi by 3. This is the value of alpha. Okay. Once you have obtained value of p and value of alpha, the next thing that you are supposed to do is simply write this equation further in this particular form. Therefore, x cos 2 pi by 3 plus y sin 2 pi by 3 is equal to 4 is the required normal form. That's the first thing. Alpha, where alpha is equal to 2 pi by 3, that is angle made by perpendicular with x-axis, and the length of perpendicular is 4. Although these two things are already known to us, but that's the next thing that was asked in this particular question. Right, that's all that you have over here. Let's discuss the second part after this, and we also need to discuss the third part. So let's get rid of all of this over here. Okay, and let's talk about the second part after this. Okay, what does the second part say? So in second part you have y minus 2 is equal to 0. This becomes equal to y equal 2. Okay, and what does this give me actually? Coefficient of y, coefficient of x is 0, 0 plus 1 square upon under root, and that will give me actually 1. So we'll have to divide by 1 at max, and yes, this can further be written as x cos alpha, that is 0 cos alpha, x times 0 plus y times sine of something. So this is sine alpha is equal to 2. That's what you get. And what's the value of sine alpha? Do you observe that sine alpha is equal to 1? If sine alpha is equal to 1, cos alpha is 0. This tells me that alpha will be equal to pi by 2. If alpha is pi by 2, therefore required normal form will be x cos pi by 2 plus y sin pi by 2 is equal to 2. And once I have alpha, I can also find the value of p easily, which is 2. That's the answer for this question over here. That's the complete second part, as you can see behind me. That's the second part for us, right? What about the third part? So let's begin the third part over here. Next, third part says you have x minus y is equal to 4. Let's begin with this, x minus y equal to 4, and 1 square plus minus 1 square. What is that? Under root of 1 square plus minus 1 squared. What is that equal to? Under root of 2. So let's divide by this under root of 2. That's what we are supposed to do. So let's divide by under root of 2 over here, and let's divide by under root of 2 over here. This becomes 1 upon square root of 2 x plus minus 1 upon square root of 2 y is equal to 2 root 2. This is what we have, and this is the required form, x cos alpha plus y sin alpha is equal to this. This is the required form, x cos alpha plus y sin alpha is equal to p, where the important thing is that cos alpha and sin alpha are known. From here I know cos alpha is equal to 1 by root 2, sin alpha is equal to minus 1 by root 2, and this tells me that alpha lies in the fourth quadrant, since cos is positive, sin is negative, and this tells me that alpha will be equal to 2 pi minus pi by 4, which is 7 pi by 4. Now this is directly from trigonometric equations, the chapter trigonometry which you have dealt with. Okay, once you get alpha is equal to pi by 4, therefore equation, the required equation becomes x cos 7 pi by 4 plus y sin 7 pi by 4 is equal to p, which is 2 root 2 over here. This is what we have, right? That's the equation where p is equal to 2 root 2. That's the perpendicular distance. Alpha is 7 pi by 4. That's something which we have already found. That's the complete solution of this. This is the third part of this third question, as you can see behind me. The fourth question says, find the distance of the point minus 1 comma 1 from the line this. Okay, very interesting. So do you recall the formula of distance of a line from some particular point? If this is line L in the form ax plus by plus c is equal to 0, if this is line, and this is some point P x1 comma y1, then we are interested in this perpendicular distance. This perpendicular distance d is equal to what? It is simply equal to, substitute this point and this line, we get ax1 plus by1 plus c. Now since this point is outside, this will not be 0, and you also divide by under root of a square plus b square. At the end you should also take a modulus. Okay, you can take the modulus of only the numerator, because this is always positive, right? So this is also okay, or taking a modulus in the numerator is also okay, right? There is nothing wrong in both of these approaches. The first thing that you observe is line is written in this particular form. That's the general form of equation of line. Here it is not the general equation. So let's try to convert this into the general equation over here. So we have point P, which is minus 1 comma 1. This will be the distance d, where line is 12 times x plus 6 is equal to 5 times y minus 2, right? So Let's try to rearrange this. This is 12x minus 5y plus 72 plus this is 82 is equal to 0. Okay. Therefore, D is simply equal to 12 times minus 1 minus 5 times 1 plus 82 upon under root of 12 square plus 5 square, a square plus b square. Taking modulus in the numerator is also okay, as I said, because this denominator is always positive, right? This is minus 12 minus 5, which is minus 17. 82 minus 17 will be 65, and this here is, as you may recall, these are Pythagorean triplets, right? This will be equal to 13, and this tells me D will be equal to 5. This is the answer of this question, as you can clearly see. Distance in terms of whatever units. So 5 unit is the answer. That's what you can say, right? This is a complete solution of this question. The fifth question says that find the points on the x-axis whose distances from the line this are 4 units. Okay, points on the x-axis are being asked. Okay, let's talk about points on the x-axis. Line is x by 3 plus y by 4 equal to 1. Let's try to rearrange this a bit. Let's multiply by the LCM of 3 and 4, which is 12. This becomes 4x plus 3y equal to 12, which is minus 12 is equal to 0. This is the equation of line. And if this is the line and this here is the x-axis, this is line. What are we asked? We are asked to find points on the x-axis whose distance from the line this are 4 units. Okay, so point on the x-axis will be P, and the distance of P is equal to 4. That's what the person is given, right? Any point on the x-axis will be h comma 0. This is any point on the x-axis, right? And if distance of this point from line L is h, therefore h will be equal to what? Sorry, distance is 4 and the point is h comma 0. So therefore you can clearly note that distance will be 4h plus 3 times 0 minus 12 upon under root of 4 square plus 3 square. The modulus is equal to what? Is equal to distance, which is 4. This is given to me, right? Okay, this tells me that 4h minus 12 and its modulus divided by 5 is equal to 4, or you can clearly say that 4h minus 12, the modulus is equal to 20. On the basis of this, you get 4h minus 12 is equal to 20, or 4h minus 12 is equal to minus 20. This is what you observe, right? This tells me 4h is equal to 32, or h is equal to 8. Or you get 4h is equal to minus 8, which tells me h is equal to minus 2. So point could be points on the x-axis, therefore points. The person also mentioned points, right? If you clearly observe, the person also mentioned points. So points will be 8 comma 0 and minus 2 comma 0. These will be the points on the x-axis which are at a distance of 4 units from this given line. That's the answer for this particular question over here. The sixth question says find the distance between parallel lines this and this. Okay, we have another part after that. Second part also says distance between parallel lines this and this. Okay, let's take a look at this question. So for finding distance between parallel lines, let's take a look at the concept behind that. This is L1, let's say, and this is L2, let's say. The equation is ax plus by plus c1 is equal to 0. And for a parallel line, the coefficient of x and y will be same. If these are the equations, mind you, coefficients could be proportional as well, but you'll have to make the coefficient same for applying the given formula, the formula that I'm using over here. If the coefficients are exactly same for x and y, in constant terms will be difference, the distance, the perpendicular distance. In that case, this perpendicular distance d will be equal to c1 minus c2, its modulus, and under root of a square plus b square, right? And don't be confused, a square and b square, a and b are same, therefore a square and b square will be same in case any equation can be used over here, right? So that's the distance between these two parallel lines. Let's talk about the first part. So we have 15x plus 8y minus 34 equals 0. Another line is 15x plus 8y plus 31 is equal to 0. Therefore, distance between the parallel lines will be equal to this minus this, which is 31 minus or minus 34 will become this upon under root of 15 square plus 8 square and its modulus. 15 is 225 and this is 64 becomes 289, which is 17 squared. So this is 65 upon 17. Overall, this is 65 upon 17 and that's my answer for this question over here. 65 upon 17, since it is distance, it can be said 65 upon 17 units. Right, the next part, second part says you have, okay, lines are given in terms of, let us say some L and P are given as coefficient. L times x plus y plus P is equal to 0. Then you have L times x plus y minus r is equal to 0. If you observe, the coefficient of x is L, coefficient of y is also L. Coefficient of x is L, coefficient of y is L. That's the condition which we wanted to satisfy, and that is satisfied, that the coefficients are exactly same. Therefore, distance will be equal to C1 minus C2, which can be written as minus r minus p or p minus of minus r. This becomes this upon under root of coefficient of x is L squared plus y is L again squared, and you take the modulus. So this is modulus of p plus r upon root 2 times L. The modulus will be taken for L as well. So p plus r upon root 2 and you take modulus for L as well, or you can take the complete modulus over here. That's what you can observe, right? So instead of taking only modulus of L, you can take the complete modulus and that will take care of this. I can write modulus of L as well, but that's okay, right? Since modulus of x upon modulus of y is modulus of x upon y, this is true, and yes, that's the distance over here between the parallel lines given in the second part. That's the complete solution of this question. The seventh question says that find equation of the line parallel to the line this and passing through the point this. Okay, pretty interesting. Find equation of line parallel to this and passing through the point this. If this is L1 and you need another line which is parallel to this, L1 is ax plus by plus c is equal to 0, and if you need another line which is parallel to this, then the equation can be written, since the slope will be same, the equation can be written as coefficients will be exactly same plus the constant term will be different. What have you actually done? You have actually made the slopes of these two lines same, right? That's what you have done. So if this is the given line, this will be a line which is parallel to that given line. The only thing which is unknown is this d. So for finding d, you will be given another condition. Finding d, you will be given another condition, and yes, that is a condition given over there. That point, that line passes through minus 2 comma 3. So this is what we can do over here in this question, and we can easily get the answer, right? But then if you face difficulty in writing this, so what you can do is you can first find the slope of the first line, which will give me the slope of the second line as well, right? Since the slopes are exactly same. So let's begin with an alternative idea that L1 is 3x minus 4y plus 2 is equal to 0. This tells me that 4y is equal to 3x plus 2. This tells me y equals 3 by 4 x plus 2 by 4, which is 1 by 2. And this here is the slope. Therefore, m for this L1 is 3 by 4. Okay, m for L1 or m1 is 3 by 4. Implies m for L2, which we require, is also 3 by 4 since the lines are parallel. Slopes will be same. Okay, and point is given. Point is given to be minus 2 comma 3. Okay, so what you'll get is basically using this point and this slope, you will get the equation of line. What is the formula that I'll use? I'll use the point slope form, which is m times x minus x1. This is equation of line and point slope form. So therefore, equation becomes y minus 3 is equal to 3 by 4 times x minus or minus 2, which becomes x plus 2. This is further equal to 4y minus 12 is equal to 3x plus 6, and this simplifies to 3x minus 4y and plus 18 is equal to 0. This is what you get, 3x minus 4y plus 18 is equal to 0. This, we started with this and we obtained the other equation, and that's my answer for this question. If you observe carefully, Initially we began with this idea and we could have solved the complete question with this. For finding D, we'll simply use this condition, right? And how will we use that? How will we use that? So we have this L2 will be equal to 3x minus 4y. Since this is 3x minus 4y plus 2 is equal to 0, this becomes plus D is equal to 0, right? This is a simpler approach, easier approach. And for finding D, you substitute the point minus 2 comma 3 on this and find the value of D. This becomes minus 6 minus 12 plus D is equal to 0. This tells me D is equal to 18. Do you observe that? Yes. And substitute that 18 over here. This gives me that same equation. Same equation. But here you have used concept of finding the slope first, then using idea of parallel. And here you have all taken all of that into account by simply writing this equation. Right? This is a simpler approach, but the NCERT people prefer this kind of approach. If you want, you can follow this one as well. This is the easier and simpler approach which you can always use for such kinds of questions, right? This is question number 7 for us. The 8th question says, find equation of line perpendicular to the line this and having x-intercept 3. Okay. So for perpendicular, do we have some kind of simple trick? Yes, we have a simple trick for perpendicular as well. Okay. If this is L1, this is L2, and the equation of L1 is, let us say, ax plus by plus c is equal to 0. The equation of L2, mind you, this is not given directly in the NCERT, but if you want, this is bx minus ay plus d is equal to 0. Once again, the coefficients of x and y on the basis of that, what we have done is interchange them and introduce a minus in between. The only thing that will be unknown after that is this d. For finding equation of a perpendicular line, this is what you are supposed to do. And this question can be solved easily with the help of this. Given equation is x minus 7y plus 5 is equal to 0. Okay. Equation of the line perpendicular to the line this having x-intercept 3. So x-intercept 3 will imply that this line passes through the point 3 comma 0. Right. That is given to us. Okay. On the basis of this, perpendicular line will be equal to 7x plus y plus d is equal to 0. From here, I write this equation. How do I write that? Interchange the coefficients and introduce an extra minus over here. So there is already a minus, that becomes a plus. Okay, that's pretty simple. Yes, I write 7x plus y plus d is equal to 0. And now let's substitute this 3 comma 0. This is 21 plus 0 plus d is equal to 0, which gives me d equals minus 21. Therefore, equation will become 7x plus y minus 21 is equal to 0. This is the required equation. But this is using a shortcut idea, right? Can you solve this using direct concepts of slope? Yes, I can do that as well for you. So, you have L1 is x minus 7y plus 5 is equal to 0. Let's write in the slope intercept form. This becomes 7y is equal to x plus 5, which can be written as y is equal to 1 by 7 x plus 5 by 7. This here is the slope. Therefore, m of line 1, which is 1 by 7. Okay. Now, m of line 2, what will happen to line 2? This is line 1 and this is line 2, which is perpendicular. Okay. M of line 2 will be minus 1 upon m of line 1. What is that equal to? Minus 7, since lines are perpendicular. Yes, this is what is happening over here. Negative reciprocal. The product of the two slopes is minus 1. Therefore, m of L2 will be minus 1 upon m of L1, right? This is what you'll have. So, you take the reciprocal, you introduce an extra minus over there, right? That's what you have done. And once you have this, you already have a point which is x-intercept. Basically, you already have the x-intercept. So, why not use the intercept form? Why not use the intercept form? X-intercept form. X-intercept is equal to 3. And the x-intercept says that line will be equal to, y line will have equation this, x minus c. This is the equation of line that you will have, right? If x-intercept is c, this becomes x minus c, and this is a slope, which tells me y is equal to minus 7 times x minus 3, which tells me y equals minus 7x plus 21, or 7x plus y minus 21 is equal to 0 is my answer for this question. Oh, but we found that. Yes, we found that using another idea. This is the approach that you'll be looking forward to, right? And that's the final solution of this question, as you can see behind me. The 9th question says, find angles between the lines this and this. Okay, so for finding angles between two lines, we are not given the slopes directly. Had we given the slopes directly, had we been given the slopes directly, we could have directly used the result tan theta is equal to m1 minus m2 upon 1 plus m1 m2 and its modulus. The angle will be theta and pi minus theta. The angles will be this and this using this formula. But here we are not given the slopes directly. Okay, so can we find the slopes? Yes, we can find the slopes. So I would like to give you one more idea over here, some additional thing. Yes, so you already remember that y is equal to mx plus c. In this equation, the slope is equal to m and the y-intercept is equal to c, right? This is something which you already know, and we have been converting equations in this form, right, for finding the slope. But do you recall that if you have ax plus by plus c is equal to 0, can you rearrange this? You will always be able to rearrange this as by is equal to minus a x minus c, and this will be equal to y is equal to minus a by b x minus c by b, right? This is what you will be rearranging it as. And for this particular line, yes, this is the slope. So slope is equal to minus a by b. This is the important thing that I want to discuss with you. Just as a check, you can always write the slope as minus of coefficient of x upon coefficient of y. Take the ratio of coefficient of x, coefficient of y and add a extra minus over there. Multiply with an extra minus and you get the slope in all such cases, right? So slope of this line will be root 3 upon 1 with a minus. That becomes minus root 3. This will be 1 upon root 3 with an extra minus. It will be minus 1 by root 3. Yes, we can always find the slope using those ideas over there. Okay, but then will we use this? Since this is not directly given in the NCERT, we can skip this. We can use this also. We can always use this one, right? But in future for competitive exams, you'll prefer using this one, mind you. Right. So keeping this in mind, you can observe how simple was that. So L1 is root 3x plus y is equal to 1, which tells me y is equal to minus root 3x minus root 3x plus 1. This tells me m1 is equal to minus a square root of 3. That's the first slope, right? After rearranging this, L2 is x plus root 3y is equal to 1, which converts to y equals to, okay, you have root 3y actually minus x plus 1, and this tells me y is equal to minus 1 by root 3 x plus 1 by root 3, which tells me m2 is equal to minus 1 by root 3. This is what I was interested in. M2 is minus 1 by root 3. So we have M1 and M2, and now I can apply the idea of tan theta to give me the angle between the two lines. Now I can apply that idea of tan theta, right? That formula is discussed in the NCERT before exercise 10.1, and we have discussed this formula before in exercise 10.1 as well for questions related to that, right? So tan theta will be equal to m1 minus m2, which is minus root 3 and plus 1 by root 3. Minus or minus will become plus upon 1 plus m1 m2. This is what we have. Take a modulus over here. This becomes equal to what? Minus 3 plus 1, which is minus 2 by root 3 upon this is 1 plus 1 and its modulus. What is that? 2. So 2 by 2 root 3 is what I get, which becomes 1 by root 3. This is what I get. Tan theta is equal to 1 by root 3. Therefore, theta is equal to pi by 6 or pi minus pi by 6, which is 5 pi by 6. That's the angle between two lines. How do we get that? Pi minus pi by 6. Because for any two lines intersecting, if one angle is theta, the other angle will be surely pi minus theta. Right? Right? The modulus gives us the acute angle directly. The obtuse angle can be obtained using this. Right? Linear pair is formed over there and all. Right? That's the idea behind this. That's question number 9th for us and the complete solution of this question. Let's discuss question number 10th. The line through the points h, 3 and 4, 1 intersects the line this at right angle. Find the value of h. Okay, so let's draw the diagram first, or let's draw a rough sketch. What does the person say? Person says this is a line L, 7x minus 9y minus 19 is equal to 0. And there's another line through the points this and this. Let's say this is point A, which is h, 3, and there's another point B. let us say 4 comma 1, and the line joining this and this intersects this line at an angle of 90 degree. They are perpendicular. Okay, so the way of dealing with this is slope of line L, this is slope of AB, that's what we can find, and the condition that we will apply is ML dot M of AB. Since these are perpendicular, the slope, the product of the slopes will be simply -1. That's a simple idea that we want to apply. Now writing slope of AB is very simple because 2 points are given. We can always write it as y2 minus y1 upon x2 minus x1. That's the slope of AB. What about slope of line L? Just in the previous question we discussed, okay, coefficient of x upon coefficient of y, 7 upon 9, 7 upon minus 9, add an extra, multiply with an extra minus, you get 7 upon 9 as a slope. Okay, but that's not the way, there's another way, right? And we follow that way for the NCERT people. So what do they tell us? That 9y is equal to 7x minus 19. Write it in the slope intercept form. And now divide by this 9, this becomes 7 by 9 x minus 19 by 9. This tells me m of line is equal to 7 upon 9. Okay, m of line. M of AB can be found easily. M of AB, let's take the points. This is 3 minus 1, y2 minus y1 upon h minus 4. This is 2 upon h minus 4 is what I get, right? M of AB. Therefore, m of L into m of AB is equal to -1 implies 7 by 9 into 2 upon h minus 4 is equal to -1, and this tells me that, okay, this is a 14, let's bring that minus over here, and on the right hand side you get 9h minus 36, okay, and what else, 9h will be equal to 36 minus 14, what is that, that's 22, and this further tells me h will be equal to 22 upon 9, which is the required answer for this particular question over here. This is 22 upon 9. That's the final answer for this particular question. This is question number 10 for us. Yes. Question number 11 says, prove that the line through the point x1 comma y1 and parallel to the line ax plus by plus c equals to 0 is a times x minus x1 plus b times y minus y1 equal to 0. Pretty interesting. You get some kind of formula also here, and you can memorize this formula for later uses, right? So prove that the line through the point x1 y1, okay, and parallel to this line. So you have a given line L, ax plus by plus c is equal to 0. This is a given line. This is L1, let us say, and you need another line which is parallel to this, L2, let's say, and this L2, the equation is supposed to be found over here. This line L2 passes through this point P x1 comma y1. Okay, so special thing about L2 is that its slope will be same as this L1, and it passes through this particular point. So let's begin with L1 first of all. L1 is ax plus by plus c is equal to 0. This can be converted as y is equal to minus ax minus c over b and b, and this here gives me the slope. This is m of L1 is equal to minus a by b. Okay. On basis of this, you can easily say that therefore m of L2, since it is parallel, the slope will be same, since parallel lines. Yes, this is something which you can say. Okay, once we observe this much, then we can also say that there is another point P x1 y1, another condition, that is the point P x1 y1 lies on this line. Using these two, you can write the equation using point slope form that says y minus y1 is equal to m which is times x minus x1, and what is this giving me? This is b times y minus y1 is equal to minus a times x minus x1. Let's bring this term over here. This tells me a times x minus x1 plus b times y minus y1 is equal to 0. Okay, this is a y1, right? So y1 equals 0 is the equation of this L2, hence proved. That's the equation of line which is parallel and having and passing to the point x1 y1, and this is what we started with proving to, right? This is what we wanted to prove. That's a complete proof of this question. You can memorize this result for further applications as well. Right? Very specific result, but yes, you can do that. Question number 12 says, two lines passing to the point 2, 3 intersects each other at an angle of 60 degree, intersect each other. It should be intersect each other. Two lines passing through the point this intersect each other at an angle of 60 degree. If slope of one line is 2, find equation of the other line. Okay, pretty interesting. Let's say we have two lines passing through the point 2 comma 3. Okay, this is a point 2 comma 3 which is a common point, and this is L1, this is L2. Let us see. Okay, and if slope of one line is 2, intersect each other at an angle of 60 degree. This particular angle is given as 60 degree, let's say, the acute angle. The other angle will be 120 degree, but we are not interested in this one. At an angle of 60 degree, if slope of one line is 2, this is L1 and the slope M1 is 2. The slope M is not known for this. Okay, let's call this M2. M2 is not known and the equation is also not known. This L2 has to be found. Okay, we are supposed to find the equation of this L2, the other line. Okay, so how do we deal with this? Right, one thing is given, this is angle is 60 degree and we can apply concepts of tan theta is equal to M1 minus M2 upon 1 plus M1 M2. Its modulus will be equal to this, right? That is something which you can apply, and using this I can maybe get a value of M2, right? If I get M2, I already have a point. I can use the point slope form to get the equation of line L2. It's pretty simple, right? So let's do the calculations now. Therefore, tan 60 degree is equal to M1, which is 2 minus M2 upon 1 plus M1, which is 2, and M2, the modulus. Tan 60 degree is square root of 3, right? This is square root of 3. So 2 minus M2 upon 1 plus 2M2 modulus will be equal to root 3, or this becomes plus or minus root 3. This or this. You can say this or this. Let's try to solve for M2 over here. This tells me that 2 minus M2 is equal to root 3 plus 2 root 3 M2. Or you can have 2 minus M2 is equal to minus root 3 minus 2 root 3 M2. This is what you will get. Is that okay? Yes. This is what you get. Let's bring terms having M2 on the right hand side, or on one side. This is 2 minus root 3 is equal to 1 plus 2 root 3 times M2. Actually, this tells me M2 will be equal to 2 minus root 3 over 1 plus 2 root 3. This is the value of M2. Okay, or you can have another value of M2 as well, which will be obtained using this idea. This 2 root 3 minus 1, M2 will be minus 2 minus root 3 over 2 root 3 minus 1. This is the other value of M2, this or this. Okay, once you have found the two values of M2, it is time to find the equations using these two values of line 2. So for line 2, I have point is 2 comma 3 M2. This is what you have. So equation will be equal to y minus 3 is equal to M2 times x minus 2. Okay, we'll have y minus 2 is equal to M2 times, y minus 3 is equal to M2 times x minus 2. This will be the equation. If this is the equation, y minus 3 times this 2 minus root 3 upon 1 plus 2 root 3 x minus 2. This will be one of the equations, or there will be another equation. We'll solve that later for this particular value, but let's simplify this further. This becomes 1 plus 2 root 3 y minus 3 minus 6 root 3 is equal to 2 minus root 3 x, and multiplying by this minus 4 plus 2 root 3 is what I get. Let's simplify this and bring everything on one side. This is 2 minus root 3 x minus 2 root 3 plus 1 y, and this becomes 3 minus 4, which is minus 1 minus 6 root 3. This becomes plus 8 root 3 is equal to 0. This is one equation. This is one equation. This tells me this is one of the equations. Let's check the calculations once. This is 2 minus root 3, 1 plus 2 root 3, y minus 3 x minus 2. This becomes 1 plus 2 root 3 minus 3 minus 6 root 3, 2 minus root 3 times x, and minus 4 plus 2 root 3 is what I get. And this comes over here. This is minus 1 root 3 and this is plus 8 root 3. This will also come on this side and this will become minus, right? That's one of the equations, or the other equation can be obtained using this value of m2, right? The other equation can be obtained using this particular value. This tells me y minus root 3. Sorry, y minus 3. Once again, this is y minus 3, right? Y minus 3 is equal to minus of 2 minus root 3. You can take a minus common and you have 2 root 3 minus 1 times x minus 2. This is what you get. Let's rearrange the equation. Let's rearrange the equation and see where does that take us. Okay, let's use a different color. This is y times 2 root 3 minus 1 minus 6 root 3 and plus 3 is equal to, on the right hand side you have minus x times 2 plus root 3 and you have plus 4 plus 2 root 3. Where will that take us? Okay, this will take us, let's bring this x term on the left hand side. This becomes 2 plus root 3 times x plus 2 root 3 minus 1 times y and minus 1 minus 8 root 3 is equal to 0. This is the other equation that I'll get. That's my answer for this part. This is first part. Okay, this or this. There are two possible answers. Yes, and we have found them. Now where are we getting two possible answers? Basically this is the line L1 which is given, and there's another line L2 which makes an angle of 60 degree. This can be this side or can be this side as well. So you'll get another L2 prime over here. This is what I'm getting over here. Since angle 60 can be formed in this way as well, therefore we are getting two answers. Pretty long answers, but yes, that's the complete solution of this question over here. As you can see, complete thing over here behind me. Right? This is question number 12 for us. Question number 13 says, find the equation of the right bisector of the line segment joining the points this and this. What do you mean by right bisector? Right simply implies the right angle, right? And bisector means the bisector of the line segment joining these 2 points, right? So you're actually looking forward to the perpendicular bisector. Actually, that's what the person wants us to find. So let's take a look at this. There are 2 points. Point A is 3, 4. Point B is -1, 2. And you're looking at perpendicular bisector, right bisector, which is this bisects this particular line L, which is question mark. L is supposed to be found, and it bisects the line segment joining these 2 points, and it is at right angles to this line segment AB, right? So if this is slope of AB, this is slope of M, I have a relation between M and M of AB. M is equal to -1 upon M of AB, right? Since the lines are perpendicular. Okay. And do I have this point P as well? Yes. P can be found easily by using midpoint formula. Midpoint formula says you have x1 plus x2 by 2 plus y1 plus, sorry, this is comma, and this here should be this. So this is x1 plus x2, y1 plus y2 by 2. These are the coordinates, and using this you can identify that 3 minus 1, which is 2 by 2, becomes 1, and 4 plus 2, 6 by 2 becomes 3. This is point P. Okay. What is M of AB? M of AB is y2 minus y1 upon x2 minus x1, which is 2 minus 4 over -1 minus 3. That is -2 upon -4, which is 1 by 2. Therefore, M, the slope of line ML will be negative reciprocal of this, which is -2. You have this and you have the point. Using these two, you can write the equation of line L in the point slope form. So line L will be y minus y1 is equal to m times x minus x1. What is that? This is a form that I'll be using. Y minus y1 is equal to m times x minus x1. This tells me 2x plus y, and this is 2 becomes -5. This is what you get. 2x plus y minus 5 equals to 0. This is the equation, required equation of the line L, which is the right bisector of the line segment joining the points this and this. Yes, that's the complete solution of this particular question. The 14th question says, find the coordinates of the foot of perpendicular from the point this to the line this. Okay, foot of perpendicular from the point this to the line this. Pretty interesting, very interesting, very important question, right? So if this is line L is given to be 3x minus 4y minus 16 is equal to 0, and this is point P. Let's say which is minus 1 comma 3. What are we asked? We are asked to find this foot of the perpendicular M. Okay, we are asked to find this foot of the perpendicular M. Let's denote M by H comma K, and we'll find H and K, right, somehow. Okay, one particular result is a direct result which we can follow and which we can use to find the foot of the perpendicular easily. I'll explain that formula first, and then we'll solve this question using basic concepts, right, basic methods. First let's solve using basic concepts, and let's verify after that using the formula. Okay, we'll verify later on. Okay, let's forget about this formula first. Let's solve using the basic concepts. What are that? Because NCERT people want this kind of a thing. Coordinates of the foot of the perpendicular from the point this to the line this. Okay, so we need H and K. There are two unknowns, right? And for solving for H and K, you will need two equations maybe. So one of the equations can be directly seen that M point lies on this particular line. Therefore, 3 times H minus 4 times K minus 16 is equal to 0. This is equation number 1. It's okay. Another equation that you can observe is this is perpendicular, right? So M of PM, the slope of this PM times the slope of line will be equal to minus 1. That's what you can observe, right? If this is slope of L and this is PM, slope of PM. What is slope of PM equals to? Slope of PM will be K minus 3 upon H plus 1. This is the slope. What is slope of L? So for that we can write it in the slope intercept form. This is 4y is equal to 3x minus 16, or y is equal to 3 by 4x minus 4, and this here is the slope. 3 by 4 equals minus 1. And on rearranging this, what do we get? This will further tell me that 3k minus 9 is equal to minus 4h minus 4, which tells me 4h plus 3k and minus 5 is equal to 0. This is equation number 2. This is equation number 2. Yes, this is what you get. 4h plus 3k minus 5 is equal to 0, and you had 3h minus 4k minus 16 equal to 0. This is equation number 1. Okay, can you solve these two equations to get the values of H and K? Yes, we can solve these two equations to get the values of H and K easily. For that, okay, one of the approaches which you can follow is elimination, the other is cross multiplication. And what would I like to use? This is 3, this is 4. So let's multiply equation 2 by 4 and add with equation 1 multiplied by 3. Okay, equation 2 multiplied by 4, this becomes 12, and this times 3 becomes 12 over here. Adding them will eliminate k. Okay, and what will this become? This is equation 2 multiplied by 4, 16 plus 9 is 25h, and as k is gone, you get minus 20 and minus 48 is equal to 0. This is what I am getting, right? This tells me h will be equal to 68 upon 25. H comes out to be 68 upon 25. Pretty interesting. Let's check the value. Okay, 68 upon 25 once. So what I'll be getting is, this is 4 times this is 20 and 3 times this is 48. So adding them will give me minus 68. Yes, and 68 will go on that side, and this is what you'll be getting, right? These equations seem correct. That's not an issue. This is correct for sure because we have noted the equation of line properly, and if the slopes have been noted, k minus 3 h plus 1 times 3 by 4 is the slope. So 4h plus 4 with a minus 3k minus 9, 4h plus 3k becomes 5 on the right hand side, or minus 5 over here. And that's also correct. So everything seems correct. H is equal to 68 upon 25. What's the value of k? K can also be found using any of these equations, or for that matter we can use a similar idea here. That is, we can multiply this by 3, we can multiply this by 4 and subtract. Okay, so multiply equation 2 by 3 and subtract equation 1 multiplied by 4 from here. Okay, this times 3 is 12h and this times 4 is also 12h. They will get subtracted. This times 3 is 9 plus 16 will be 25k. Next we have minus 15. Okay, and 1 into 4 will be 64, but there is an extra minus over there, so that becomes plus 64. Okay, equals 0. On the right hand side you have a 0. This gives me k equals 64 and 15. That will subtract 2, give me 49, and this becomes minus 49 upon 25. Okay. So the vertex, the coordinates of M will be 68 upon 25 comma minus 49 over 25. That's what you have, right? Okay, this is using the direct approach, and we can also get the same result using another approach. What's that other approach? Using a direct formula. As we discussed, we'll say spend some time on that as well. Right. So in case you have any line AX plus BY plus C equals 0, and you need for this point P x1 y1, if you need this perpendicular distance D, sorry, not this perpendicular distance D, if you need the foot of perpendicular, right? If you need the foot of perpendicular, this M, let's call this x2 comma y2. If you need the coordinates of M, so the direct result which says that x2 minus x1 upon this upon A is equal to y2 minus y1 upon this B is equal to minus 1 times what you have is ax1 plus by1 plus c upon a square plus b square. Mind you, there is no modulus, there is no under root in the denominator. This is the result that we can use to get foot of the perpendicular directly. This is a result that we can use to get the foot of the perpendicular directly. This expression can be calculated with the help of this and this, and using this with this we get x2, using this with this we get y2. This is x2, this is y2, we can calculate and check, right? This is something which you can do on your own, and yes, this is the final answer for this particular question, as you can see behind me. The 15th question says perpendicular from the origin to the line this meets it at the point this, find the values of M and C. Okay, pretty interesting. So perpendicular from the origin to the line this, minus 1 comma 2, this is some point minus 1 comma 2, and there is a perpendicular from the origin which meets a line. Okay, if this is perpendicular, then this line will be perpendicular, right? This is minus 1 comma 2, this is point P, let's say. Okay, and this is the origin O, 0 comma 0. This is perpendicular, it meets the line L at this particular point, and line y is equal to mx plus c is the line. Okay, okay, and you are supposed to find M and C. Now how will we find this? So sometime back we had solved a question where the equation of this line was asked, right? Can we use a similar idea over here as well? Yes. So for finding this equation of line, we already have a point. For the line we have a point P which is minus 1 comma 2. We can also find the slope. Now M of line is equal to minus 1 upon M of OP. Can you please observe that? Yes, since OP is perpendicular to the line, therefore this is the formula that we'll have. And what is M of OP? M of OP is pretty simple. M of OP will be the slope for y2 minus y1, 2 minus 1 upon 2 minus 0. 2 minus 0, minus 1 minus 0, what will that be? Minus 2. Therefore, M of L will be reciprocal with a negative. This is this is 1 by 2. We already have the point and the slope now. So with the help of this, I can find the equation very easily. Y minus 2 will be equal to, what do we have? Slope times x plus 1. That tells me that y is equal to 1 by 2 x plus 1 by 2 plus 2, which tells me y is equal to 1 by 2 x plus 5 by 2. This is in this required form, right? We wanted to answer in this form. Therefore, M is equal to 1 by 2 and C is equal to 5 by 2. That's my answer for this question. Okay, is that all? Yes, that's all that you have for this one. So, could we solve this question using some other idea as well? Yes, maybe we can solve this question using an alternative idea, that is using concepts of simple plane geometry. Simple plane geometry, yes, this is coordinate geometry, but you can use simple ideas of geometry. And how's that? So, one thing is the M, the value of M, which has been found over here, isn't it? Yes. So that was very simple. Yes. The other thing that you wanted was the C, right? That's the y-intercept, right? And for finding that y-intercept, you observe that this is a right angle triangle. Okay, okay. And what else am I interested in? I am interested in if I want this distance and I have the slope. So I have this complete tan theta, so I can easily find this angle and tan theta for this angle as well, which will be modulus. And yes, This will be easy to find, right, for this particular angle. After that, what we will solve for is, once this angle is known, or for that matter theta for this angle is known, tan theta, then we can use that tan theta with this distance and this distance to get this particular value over here, right. Please observe, if m of L is 1 by 2, therefore this angle is theta. If this angle is theta, then tan theta is equal to 1 by 2, right. So which angle can be easily found? If this is theta, this complete is 90 degree, this is 90 minus theta, therefore this again will be theta, okay. And for this theta and this right angle triangle, this is the hypotenuse, this is the adjacent. So you need cos theta is equal to base upon hypotenuse, which is OP upon this C distance, right. So C will be equal to OP, which is this distance, which is root 5 upon cos theta. Now what is cos theta? If tan theta is equal to 1 by 2, cos theta will be equal to, can you find that? Yes, 2 by root 5. So this will be 2 by root 5 and this further becomes 5 by 2. Now I have done some fast calculations over here, but I think you can deal with that. With the help of tan theta, you can easily find cos theta, and you can easily find OP with the distance formula. So C will be equal to 5 by 2. This will get C is equal to 5 by 2 from there as well. Right. So this is using simple geometry ideas, we can solve this question over there only. But using equation of Lionel, this is the approach, and therefore these are the possible values. These are the values of M and C as we have found over here. That's the complete solution of this question. Question number 16 says, if P and Q are the lengths of perpendiculars from the origin to the lines this and this respectively, prove that P square plus 4Q square is equal to K square. Let's take a look at this question. Lengths of perpendiculars from the origin to the lines. Okay. So formula for lengths of perpendiculars, let's recall that. P x1 comma y1. If this is L, ax plus by plus c is equal to 0 and this is distance d, d will be equal to ax1 plus by1 plus c upon under root of a square plus b square. Modulus can be here or complete modulus. This is what we have for distance, right? That's the formula that we'll need. In this question, what do we have? P and Q are the lengths of perpendiculars from the origin. Origin is 0, 0, x1, y1 becomes 0, 0 to the lines this and the lines this, okay. So P is equal to, so you substitute 0, 0 on this, 0 minus k cos 2 theta upon under root of a square plus b square, which is cos square theta plus minus sine square theta, minus sine theta square will be this, and you take a modulus. This is P for us, okay. Q will be equal to again 0, 0 minus k, you bring this k upon under root of a square plus b square, which is sec square theta plus cosec square theta, okay, and you take a modulus with this. This is what we have. Respectively, prove that P square plus 4Q square. We are interested, after this we are interested in P square plus 4Q square. These are the corresponding values of P and Q, and see where does that take us. So let's apply. This will be equal to what? This is k cos 2 theta, and in the denominator you have 1. So P square will be equal to k square, the modulus will go, this is k square cos square 2 theta, this is positive, right? And in the denominator you have under root of 1, which is 1 squared will also be 1. So P square is equal to this. What about Q? So Q squared will be equal to k square in the numerator, and in the denominator you will have sec square theta plus cosec square theta, okay. This is what you have. And can I simplify Q square first of all? Yes. Let's try to convert this also in terms of sine and cos. This is 1 upon cos square theta, this is 1 upon sine square theta. By the way, let's multiply with sine square theta and cos square theta in the numerator denominator. This becomes k square sine square theta cos square theta, because here in the denominator you have 1 upon cos square theta, this will be equal to sine square theta. On multiplying by sine square theta, cos square theta, this will become cos square theta. Denominator is simply equal to 1, yes. Okay, this is pretty simple. This is k square times sine square theta times cos square theta. This is what I have. Now what are we looking forward to? We are looking forward to P square plus 4Q square. Therefore, P square plus 4Q square is equal to K square cos square 2 theta plus 4 times Q square, 4 times K square times this sin square theta cos square theta. Now how do I simplify this expression? So for that, do you observe that this 4 sin square theta cos square theta is actually nothing but 2 times sin theta cos theta whole square, right? So K square cos square 2 theta. Let's take this K square outside. This remaining thing is 2 times sin theta cos theta and its square. And what is this? Sin 2 theta is 2 sin theta cos theta. This can be done as sin 2 theta square. This is cos square 2 theta. Yes, now you can guess this is cos square 2 theta plus sin square 2 theta, and yes, since the angles are exactly same, this will be 1. This is K square times 1, which is equal to K square. So P square plus 4Q square is equal to K square. Hence proved. That's the complete proof of this question, as you can see over here. The 17th question says, in a triangle ABC, with vertices this and this, find the equation and length of altitude from the vertex A. Oh, how do we find the length of altitude? Let's see. So you have, let's mark some random triangle. This is A, this is B and C. Without lots of generality, this is 2, 3, this is 4, -1 and this is 1, 2. If you want the altitude from vertex A, this is the line that you are looking forward to, this AD. We are interested in AD. So for AD, there will be two things which are required. For AD, you already have the point A, which is 2, 3. And another condition that is required is maybe the slope, since perpendiculars are involved, yes. If this is M of AD, this is M of BC, you can clearly observe that M of AD will be equal to -1 upon M of BC. So we are interested in slope of BC first of all, right? Let's use that. M of BC, the slope of line segment BC is this, y2 minus y1, which is 2 plus 1 upon 1 minus 4. What is that? 3 upon minus 3, which is -1. And using this, M of AD will be equal to, reciprocal with the minus, this will be equal to 1. Okay, you already have the point, you have the slope now. Therefore, equation of AD will be y minus y1 slope times x minus x1. This implies, what do you have? X minus y and plus 1 equals 0. So this is the equation of AD. That's something which we have found, right? Equation of the altitude from vertex A. That is something which you have found, right? And what else? Okay, find the equation and length of altitude is also being asked, right? So how do we find the length of altitude? That's simply perpendicular, right? Length of the perpendicular. Can we find that directly maybe? This is altitude, okay, and AD is the length. So for that, either we find D first of all, that's the foot of the perpendicular, or we write the equation of BC, and with the help of that, we write perpendicular distance. So let's focus on the second part. This is first part, the answer for the first part. Let's focus on the second part, which says that for AD, we need the perpendicular distance. Therefore, maybe write the equation of BC first of all. So for writing the equation of BC, you need 2 points, which are 4, -1, 1, 2. Let's use these 2 points to write the equation. Y plus 1 will be equal to something times x minus 4. This is what we have. And this will be 2 plus 1. M of BC. We have already found M of BC, right? This is -1. That's the slope. So this becomes x plus y. X comes over here. Y is already there. This becomes 4. And this comes over here, -4. 1 minus 4 is -3. This is the equation of line BC. Therefore, AD, the distance is equal to modulus of, for point A, let's substitute this, 2 plus 3 minus 3 upon under root of 1 square plus 1 square. This is AX1 plus BY1 plus C upon under root of A square plus B square. This is 2 upon root 2, or you can say that this is square root of 2. Therefore, the perpendicular distance is square root of 2. That's what you have, square root of 2 units. Distance is this units, right? That's the answer for this particular part, and this is the equation of altitude AD. That's what we have found, right? So in this question, we learned how to find the equation of altitude. One of the altitudes had been found, right? Finding another altitude, and similarly, you can then find the points of intersection and get the orthocenter of the triangle as well. Yes, orthocenter is the intersection point of the altitudes, right? In one of the previous questions, we studied something called finding the equation of median, right? Median forms of vertex R. So using median, right, you can find the equations of median. That's something which I've learned. Oh, and the intersection point of medians is the centroid. So do we need to find the equations of median for finding the centroids? Not exactly. If the vertices are given x1, y1, x2, y2, x3, y3, the centroid is simply x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 upon 3. That's a direct formula for centroid. Although we learned how to find the medians, equations of medians, but we don't read the equations of medians for finding the centroid given the vertices, right? Okay. Another thing which you learnt is in one of the questions you found the right bisector, right? Right bisector was actually the perpendicular bisector. So if you know B and C, then we can find the perpendicular bisector of line segment BC. Similarly, you can find perpendicular bisector of another side, and the points of intersection of perpendicular bisector, point of intersection of perpendicular bisector is nothing but the circumsector, right? One particular thing remains, there are 4 types of special points. The 4th point which remains is based on angle bisectors, right? And do we learn angle bisectors over here? Not exactly. In the NCERT there is one particular question which is given, and it is not actually given in the exercises, it is given in the examples, right? And we'll see questions based on maybe angle bisector in the live session or maybe miscellaneous. Let's see. We'll see in the live session, right? Some question based on angle bisector, and maybe we'll find angle bisector on the basis of that. So if you can find angle bisectors of 2 lines, if you can find the angle bisectors, then you can maybe find 2 angle bisectors and find the point of intersection to get the in-center of the triangle as well. So this is the complete analysis. We have found the altitude and the length of perpendicular for this question, as you can clearly see behind me over here. That's all in this question. Question number 18 says, if P is the length of perpendicular from the origin to the line whose intercepts on the axis are A and B, then show that 1 upon P square is equal to 1 upon A square plus 1 upon B square. P is the length of perpendicular from the origin, okay, length of perpendicular from origin to the line whose intercepts on the x-axis are A and B. Okay, so we have this line whose intercepts are A and B. This is given, right? This is vertex A, this is vertex B. Let's say this is x-axis and this is y-axis. Are A and B respectively, basically. So x-intercept will be A and y-intercept will be B. Equation of line L will be x upon A plus y upon B equals 1. What else? If P is the length of perpendicular from the origin. Okay, you are interested in this. From the origin. Okay. To the line whose intercepts on this is, then show that. Okay, now we are talking. So we have the equation, yes, and we have the point from which we need the perpendicular distance, right? So perpendicular distance P will be equal to AX1 plus BY1 plus C. That is 0 upon A plus 0 upon B minus this 0 upon A plus 0 upon B minus 1 upon under root of coefficient of x 1 upon A squared, coefficient of y 1 upon B squared, and a modulus overall. This is what I will be getting, right? Directly applying the formula of distance. And you may observe this is simply equal to minus 1. This tells me P, and you can square this as well. Minus 1 square will be 1, and this will be 1 upon A square plus 1 upon B square. Okay. Can I cross multiply and see where does that take me? This tells me that 1 upon A square plus 1 upon B square is equal to 1 upon B square. Let's take this here, sir, and this here, sir, cross multiplying. And yes, this was the thing that we wanted to prove, right? That's all that you have in this particular question over here.